So let's take a look at the distance formula in 3 dimensions. So let's say we have 2 points. The first one is P1 or point 1 and the second one is P2 or point 2. So P1 has the coordinates x1, y1, z1 in the 3rd dimension, and then P2 has the coordinates x2, y2, z2 in the 3rd dimension. So in order to calculate the distance between P1 and P2, or the 2 points, is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and then plus z2 minus z1 squared. So the square root of the entire thing. And keep in mind, this is the way we write distance, so we always have the absolute value and then the 2 points inside the absolute value whenever you're trying to find the distance between those 2 points. So let's say that we have to show that the right triangle with vertices P, which is -2, 4, 0, Q, 1, 2, -1, and R, -1, 1, 2, is an equilateral triangle. So obviously in an equilateral triangle, all 3 sides have to be the same length. So basically what we're trying to find here is if the distance between each of these points is the same length in all 3 sides. So let's just start by writing out the vertices. So point P is going to have the points -2, 4, 0. Q is going to have 1, 2, -1. And R is going to have -1, 1, and 2. So let's first find the distance between P and Q. So if we were to find the distance, so we're going to put the absolute value around P, Q. So that distance, so let's say P is our first point. So -2 would be our x1, 4 would be our y1, and 0 would be our z1. And let's say Q is our second point. So 1 would be the x2, 2 would be the y2, and -1 would be the z2. Now in order to find that, obviously it's going to be the square root. Now we take x2, which is 1, minus x1, which is -2, so plus 2, squared, plus y2, which is 2, minus y1, 4, squared, and then plus z2, -1, minus z1, which is 0, squared. And so obviously 2 plus 1 is 3, 3 squared is 9. So we get plus -2 squared, which is 4, and then plus -1 squared, which is 1. And then 9 plus 5 gives us 14. So the length, or the distance between P and Q, the points, is the square root of 14. So now let's find the distance between points Q and R. So once again, let's make Q the first point. So we have x1, y1, and z1. And let's make R the second point. So x2, y2, and z2. So once again, we're taking the square root of x2, which is -1, minus x1, which is 1, squared, plus y2, which is 1, minus y1, squared, plus z2, minus z1, so it would be 2 minus a -1, or 2 plus 1, squared. So then we get the square root of -2 squared, or 4, plus -1 squared, which is 1, and then plus 3 squared, 9, which is also going to give us the square root of 14 as the distance between the points Q and R. So now finally, let's find the distance between R and P, or let's just put it as between P and R. So let's make P the x1s, y1 and z1. Let's make R the x2, y2, and z2. So we're going to take the square root of -1 minus a -2 squared, so -1 plus 2 squared, plus y2 minus y1, so 1 minus 4 squared, and then plus z2 minus z1, or in other words 2 minus 0, or just 2 squared. And so -1 plus 2 is 1, 1 squared is 1. Now 1 minus 4, -3 squared is 9, and then plus 2 squared, which is 4. And so we still get also the square root of 14. So since the side lengths are the same for all 3 sides, we can confirm that this is an equilateral triangle.